Hello, welcome to my paradise, and at this moment welcome to my class of the market calculus. Normally in a market equation, the power of the market determined by the demand and the supply. It crosses at the equilibrium, which is normally at the index P and the index of Q. Then the problem's coming after we try to discuss and learning the graphic like that. How can we determine or measure the function of demand and supply? So if we have two sets of data, which is that number 1 to number n for the price and quantity, we can find the relationship by placing all the things like this. So for P number 1, it's A added by B of Q number 1. P number 2 is A plus B of Q number 2, etc. So at the end, we have this total of P is n times of A plus B of sigma Q. So the first A will be the total of P eliminated by B times the total of Q divided by n. Then for the second step, we try to find the P times Q. For the first one, it's A times Q. The first Q added by B, this plus B times the square of Q number 1. And so number 2, P2 Q2 is A Q2 added by B, the square of Q2, etc. So then at the end, Pn Qn is equal to AQn added by B square of Qn. So the total of P times Q is A times the total of Q added by B times the total of square Q. So then we have two kinds of A here. We have one A at the left here and one another A over there. So if we try to combine those two, we move this one on the left and we move the n on the right. So this total of Q times total of P eliminated by B, total of Q times total of Q, which is normally square of the total of Q. And we have n over here, n times the PQ, and minus B, n times the square Q. So we collect all the B together on the left and we put non-B on the right. Then we divided those things, and that has already been the elasticity. Of the regression identified. This is the B and this is the A, so we can try to determine which one is A and another one is B. Same things will be done for the supply. C and D using this kind of price and quantity regarding the same time signal. Then how can we find the equilibrium of the crossing? The function of A plus BQ and C plus DQ will be equal at the equilibrium. Let's say at the Q, reference Q or Q0, A added by BQ0 is equal to C added by DQ0. So B minus D of Q0, we put all the Q0 together here, and we put non-Q here, C minus A, so then C minus A divided by B minus D is the Q0. So we can identify this, Q0. For the P, we try to submit the value of Q by submission here. So A added by B, Q0 is A added by B, the value here, C minus A divided by B minus D. So then altogether we have AB minus AB added by BC minus AB. So we can cross this with this. We have BC deducted by AD divided by BD is the P0. So then we can identify this. So the equilibrium coordinate will be C minus A divided by B minus D, and the coordinate will be BC minus AD divided by B minus D. So that is the coordinate of the equilibrium. Then the problem will come raised if we have not both linear demand and linear supply, but perfect demand and linear supply. So same thing does happen. We put all the things. So then we complete the point up to 0 is equal to the square equation. Since the square equation normally use this type, A of square Q added by B of Q and C, so that we can identify that A is E, B is B minus D, and C is A minus C. So altogether here will be D minus B plus minus plus and minus square root of B minus D square eliminated by 4E times A minus C divided by 2A, because for this times Q 1 and 2 is minus B plus minus square of B deducted by 4AC divided by 2A. Same thing does happen for the linear demand and perfect supply. So all the things here, and the types of the ABC with A is equal to F, B is equal to D minus B, and C is equal to C minus A. This is the equation here. So then we adopt this one also. Q1 and 2 will be minus B plus minus square root of B squared deducted by AC divided by 2A. So this is example number 2. If this one is this example number 1, this is example number 3. And for example number 4, we have both demand and supply not linear. So same thing does happen, equal the demand and the supply referring to this revert or this Q0. So that after that we put that on the ABC equation, which is A is E deducted by F, B is B deducted by D, and C is A deducted by C. So after this, you can hear that both Q is minus B plus and minuses of square root of B squared deducted by 4AC divided by 2A. So we can define this. Then the problem, how can we find the ABC here? For here we already find the ABC. How can we find the ABC here? So it is the Triviate Regression that using the formula of P1 is A plus B Q1 plus E square of Q1. So we put all two together here for Q2, Q3 and Qn. The total is total of P, it's n times of A, added by B times of total Q, added by E times of total square of Q. So then this is the for A, similar like this. And for the second it is PQ, PQ, PQ. So then we have divided by total of Q for things similar like this. And for the third one, we try to multiply all the things with the square Q. So then we have the P times square Q, and the total of that will be equal to A times total of square Q added by B, the total of cubic Q, and added by E, the total of quadruple Q. So then we have 3A here, A number 1, number 2, number 3. We put number 1 against number 2 here, and also number 1 against number 3 by using this equation, so that we can find B number 1 and B number 2. This will go there, and the n come to the right side. Here also the n come to the right side, and the total of Q square becomes on the left side there. So after we combining those two B's, B1 and B2, we can find the total E, which is normally this is the total function of that. We can find that after combining all the things all together, so we can find this is the total E. So that we can know A, B and E as well. Same thing will be happen to C, D and F of Q squared. So then we can easily identify both the triviate regression for the perfect demand and perfect supply, and also for the equilibrium coordinate by using ABC formula of Gaussian algebra. And for this one, we can easily use the geometric crossing of between two straight lines. And the estimation of the line, we can use the linear regression techniques here, which is normally bivariate linear regression. Which is coming from the set of data, come to the regression, and we can cross them. That's why we can cross both linear demand linear supply, perfect demand linear supply, linear demand perfect supply, and both perfect demand and supply all together with the estimation in bivariate regression and trivariate regression as well. Thank you.